Good afternoon, guys. Welcome back into my channel. So in this topic, we're gonna talk about Kubernetes. So this page is the Kubernetes website overview. So if you read here, Kubernetes is a portable extension, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. The name Kubernetes originates from the Greek meaning elements or pilot. K as an abbreviation results from counting the 8 letters between the K and the S. Google open sourced the Kubernetes project in 2014. Kubernetes combined over 15 years of Google experience running production workloads at scale with best of breed ideas and practice from the community. So now, guys, now going back in time, that's what like a traditional deployment will be. You have the app, you have the operating system, and you have the hardware here. Now, virtualized deployment will be the app, the main library, the operating system, the virtual machine, the hypervisor, the operating system, and the hardware. Now, the containers deployment will be the app, the main library containers, and the container runtime, the operating system, and the hardware. It's kind of explain everything here, like traditional deployment error. Early on, organization want application on physical server. There are no way to define resource boundaries for applications in a physical server, and these cause resources allocation issue. For example, if multiple applications run on a physical server, there can be instances where one application will take up more of the resources, and as a result, the other application will underperform. A solution for this would be to run each application on a different physical server. But this did not scale up. Resources were underutilized, and it is expensive for organizations to maintain many physical servers. Now, the virtualized deployment error. A solution virtualized was introduced. It allows you to run multiple virtual machines on a single physical server CPU. Virtualization allows application to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by another application. Virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware costs, and much more. With virtualization, you can present a set of physical resources as a cluster of disposable virtual machine, and each VM is a full machine running all the components, including its own operating system on top of the virtualized hardware. Now let's touch the container deployment era. Containers are similar to VM, but they have relaxed isolation properties to share the operating system OS among the application. Therefore, containers are considered lightweight. Similar to a VM, a container has its own file system share of CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, they are portable across clouds and as distribution. Containers are become popular because they provide extra benefits such as agile application creation for deployment, increased ease and efficiency of container image and creation compared to VM image use. Continuous deployment, integration, and deployment provides for reliable and frequent container image build and deployment with quick and efficient rollback due to image immutability. DevOps separation of concern create application container image and build release time rather than deployment time, thereby decoupling application from infrastructure. Now, it's a lot that containers provide as benefits. So you could come to this website and look at this yourself. Why you need Kubernetes and what it can do. So containers are a good way to bundle and run your application in a production environment. You need to manage the containers that run the application and ensure that there is no downtime. For example, if a container goes down, another container needs to start. Wouldn't it be easy if this behavior was handled by a system? So that's how Kubernetes come to the rescue. Kubernetes provide you with a framework to run distributed system resiliently. It takes care of scaling and failover for your application, provides deployment patterns and more. For example, Kubernetes can easily manage a canary deployment for your system. Kubernetes provides you with service discovery and load balancing, storage orchestration, or automated rollout and rollback, automatic band packing, and self-healing, secret, and configuration management. What Kubernetes is not a traditional, it's not a traditional all-inclusive platform as service system, since Kubernetes operate at the container level rather than at the hardware level. So it provides some general applicable features common to platform as service offerings such as deployment, scaling, load balancing, and lets user integrated their login, monitoring, and alerting solution. However, Kubernetes is not monolithic, and these default solution or optional and pluggable. So Kubernetes provide the building blocks for building developer platforms but preserves user choice and flexibility where it is important. So Kubernetes does not limit the type of application support. So this is very interesting, I would say. Now, I create a slide. Let's just take a look at it. And so now Kubernetes. So Kubernetes, now this is not something that we can really configure in this lecture, because you will need several applications already defined. So this is much more the responsibility of an application developer. Now, if you look here, Kubernetes core concept for Azure Kubernetes Services AKS. So as application developer moves towards a container-based approach, the need to orchestrate and manage resources is important. So Kubernetes is the leading platform that provides the ability to provide reliability, scheduling of fault-tolerant application workload. So Azure Kubernetes Services, AKS, is managed Kubernetes offering that further simplifies container-based application deployment and management. But we want to understand the the technology, how it works. Why would we use it? So the core concept of these Azure Kubernetes AKS and app development is rapidly moving towards this container-based approach. Now, one way to think of container-based approach, let's say I create my own small web application, right? So let's say I create my own web application. So I pay, say for instance, Hostinger or GoDaddy or whatever host service provider, or Wix or whatever of these companies that host, like, small websites and whatever. So they tell me they can host my website, for instance, for like $150 or $200. Well, there's no chance for one website, or that's like $150 or $200 a year. There's no chance that they're going to give me a dedicated computer or even a dedicated virtual machine that has only my website on it. So not for that kind of price. I can have my own website commingle with other websites that have access to each other. So I may have one of those that was compromised and that all of them will be compromised. So a simple solution is your host provider, they would run your website in an isolated container so they could have a limited number of physical hosts that all these websites and web app just run in different containers. So in different containers. So guys, what we need to do is to be able to orchestrate and manage all the resources related to a container. Now, whenever you heard the term container, just think of it like a website or a web application is what that is. We need to take off whenever we heard that term, because that's what's going to be in the container. The container will just contain a website or on web application. But if you are a host service provider, you do have to assign a certain number of resources to my website. So a web app that I pay you as a host, well, to do that, this Kubernetes is the leading platform that gives us the ability to schedule resources and make all the application fault tolerant. So these Kubernetes services, or what called AKS, is managed by, or AKS is managed by Microsoft. It's managed by Microsoft. So if I have all of these different containers, let's talk about these containers here. If I have all of these different containers, so this could contain just some aspects of Net API, all these containers, each one contain a different application where I would step in with my Azure Kubernetes AKS, and now I can centrally manage all these containers, resources, networking, and everything related to the workloads and delivery. Of those workloads could be managed to these Azure Kubernetes services. So think of it as a way to really centralize administration over a lot of containers. So what specifically is Kubernetes? What is specifically is Kubernetes, guys? Kubernetes is a rapid evolving platform that manages container-based application and the associated networking and storage component. The focus is on the application workload, not the underlying infrastructure component. You can build and run modern, portable microservices-based application that benefits from Kubernetes and manage the availability of those application components. As an open platform, Kubernetes allows you to build your application with your preferred programming language. So let's say it's actually, so Kubernetes specifically is actually just a rapid evolving platform to manage all the container-based apps and all the components they need while all of the apps were going to be accessed on the internet. Well, maybe not all internet accessible, but they're all going to be accessible through the network. Maybe I have an application that is just going to be used by internal employees, but I want to host it on Azure. Well, if you're on premises or remote, you still connect through the internet to ultimately get to the application. So all the network component, all the stores component that could be asked to file share net allows me to manage all these type of things. The beauty of this, my company or my developer, whoever is going to manage Kubernetes, and this is a service that you can be a subject matter expert in. Microsoft has a free Kubernetes guide that is several hundred pages. So this is something you would specialize in. It's not like creating a virtual machine. it's just it's just one click and you actually do. This would be a primary responsibility of dedicated person. Now, what we're looking at here, we're not going to be a subject matter expert. You're not going to be that. So we're not going to be a subject matter expert in that. You could take a dedicated course just for these Kubernetes if you wanted a deep insight into exactly how it's set up and how it actually managed. But you would really have to be a developer because so much of these is related to development practically, guys. So all of it, so that's to be well suited to truly manage this. But the beauty is to get to focus completely on the application workloads, not the infrastructure components. So I don't care about the hardware, guys. I don't care about the virtual machine or any of that. All that is going to be completely managed through Microsoft. We solely focus on the application itself. Now, with this, you could run all modern applications. So modern, portable, microservices-based application, this will be our ASP.NET, and you know many other types of application. So with that, we would use your preferred programming language for your application. Now, this AKS as a control plane, this is managed completely by Microsoft through the Azure platform itself. So we have no interaction with that, and it's completely free. What we manage is what we pay for will actually be these Kubernetes nodes and access nodes that actually run the application themselves. So AKS is also an open source, so we can run applications that are truly wholesome, like Linux platform, Windows platform. I mean, Hibernate would support either of those. So the architecture of Kubernetes services, guys. So the architecture of Kubernetes services, Microsoft completely managed this control plane. So we would just define what they actually do, but have no interaction with these. That's just the Azure side of this. Our side will be the customer management side we'll look at. So that's the side we can figure out. This is the side Microsoft configures the component and the control plane. So let's say the Kube API server. So the API server is how the underlying Kubernetes API are exposed. This component provides the interaction for management tools such as Kubernetes dashboard. So what this does is actually expose all the Kubernetes API. And like I said, it allows us to use management tool like the dashboard and a host of other tools. So it's just integrated with that. So we would report information on those type of things. Now we have the etcd to maintain the state of your Kubernetes cluster and configuration. The highly available etc is the key value stored within Kubernetes. So what this does is nothing but to store a copy of your cluster information, your configuration information, to make it be highly available. So nothing to configure. They're just a repository for the overall configuration. Then you have like Kube Scheduler. When you create or scale application, the scheduler determine what nodes that run the workload and starts them. Now, this scheduler, it's also in the, this scheduler or Kube scheduler, when we work with scaling up or scaling out, which we've already discussed, this schedule determine which nodes application would actually run on. And so that's all this Kube scheduler will be. Now, so say when we define our scale and configuration to say if my CPU is greater than 70% for 10 minutes, that configuration is actually storing this. The scheduler will read that information. So if we scale up based on a certain metrics, then we cool down and collapse those based on falling below those metrics. So the scheduler is what actually manages that process itself. Now we have Kube Controller Manager. The controller manager oversees a number of smaller controllers that perform actions such as replicating pods and handling nodes operation. Now, what this does is manage the replicating pods, guys, handling operation that runs on the individual nodes. Now, again, these are completely managed by Microsoft. So we don't need a deep understanding of what they are. We don't interact with these. We just basically want to know they exist. So this is kind of, underpinning what, that we do not see. Our focus is what we could actually manage our administrators or developers, the customer management side of these. So down here, guys, you can see that the Kubernetes cluster architecture. So we have the Azure Virtual Machine, we have the kubelet, we have the container runtime, we have the kube proxy and containers. So now the kubelet, so when we look at the kubelet containers, proxies and stuff, we look at that architecture here. So what we have, I have my virtual machine and the network in the Azure. I have my virtual network adapter. So my Azure Virtual Network Interface or VNet, Azure Virtual Network or VNet, and you have your Azure Virtual Machine, and then we have components runs on the Azure Virtual Machine to make all of these to work to run my application. So all my services, I actually need Kubernetes nodes. So usually this is called the node. My Kubernetes that is cluster it just consists of one or more nodes. So now you could certainly have this one node, but you would have no fault tolerance or higher availability. So if you were to do that, this node would actually just a virtual machine that running in the Azure now, they will call it a node, sort of a virtual machine, but that's it. That's all that is. So this here would truly be the node concept. And if you look at a failover cluster, you could put two servers and the failover cluster, and they would just call those servers like nodes inside of another nodes, or nodes after nodes one another. So just know a node is actually a virtual machine. Now, that virtual machine does run the containers. When the Kubernetes services has all the components we actually require. So from our point of view, Kubernetes is actually running on a virtual machine. Now, what we have is a kubelet. I love that term, sounds like kubelet. So it's actually just the Kubernetes agent that processes all the requests from the control plane. The control plane we saw completely managed by Microsoft, and it's scheduled running on the request container. So the Kubernetes is what interfaces with that control plane and makes that what actually connection. That connection. Now, since I'm running this kubelet and all the containers really inside of this virtual machine, the virtual machine is what has the network interface adapter, this kube proxy is what manage all of this virtual networking. So virtual networking completely handled by kube proxy. Now, every node is going to have a kube proxy. Each node. So what it's going to do is just route network traffic. It's going to manage IP addresses for all of the services, all the containers we actually ran within our overall cluster. That's what the kube proxy does. So I think of all of these kind of components of our Kubernetes cluster. So the container runtime, this is what allows your containerized application to run, interact with all the resources, virtual networking, your storage file share. So that container runtime just integrate with the kubelet. And the container itself, so all the discussion we've had about containers and application, your app will say web app, physically run here. Everything else is just to support this application. But now I could have multiple containers actually run on this as a virtual machine, and the Kubernetes services just allow us to manage all of those. So every interesting concept, but extremely in depth when you go through the full configuration of it. But again, that's something tailored to developers. We want to know a basic overview of what the service is while we would use it and how it works. But again, this would be dedicated to a developer. I appreciate you guys just following along. Stay tuned for another lab. I'll see you soon. Bye-bye.